In this fairly brief video, what I want to do is go over how to draw circuits. So far when we've drawn circuits, I'm going to actually put a title there in a second. For example, when we drew it with the battery, we had our little battery there with the nub, and we knew that the nub was positive and this was negative. And then we attached a wire to that, then we had the bulb, and then the wire went back. That's how we drew our circuit. Here was our bulb, a little thing inside of it, and the bulb was all glowing, whatnot. All right, so here's the thing. A couple of problems with that. We said that this bulb was an example of something called a resistor, right? A resistor was anything that turned electrical energy into another form, right? Imagine we were talking about our toaster. That turns electrical energy into heat energy. How silly would it look to draw a toaster, right? If you're like giving an electrician plans, oh, this is what my refrigerator looks like. This is what my toaster looks like. This is what my television looks like. We don't draw that. That's just not the way it happens. So we're going to come up with a symbol that means anything that does that. Same thing, battery. This is what a AA or a AAA battery looks like. You know, this is what our hobby battery, 6-volt battery looks like. A 9-volt battery looks different. If you plug into the wall outlet, that's a different thing altogether, but that once again is another voltage source, right? So this battery is a generic example of what's called our voltage source, our energy source for our circuit. This is the thing that provides the potential difference, right? That place of high concentration, low concentration of electrons that forces the electrons to flow. And like I said, that could be a battery, that could be a generator, that can be, the wall outlet. And so what we want to do is have some generic symbols for doing for showing these things the same way electricians do. So here's what they are. For a voltage source, what we need to do is somehow have two ends of the voltage source. These ends are called the terminals of the battery, right? Ends, terminals of the battery. So I have a positive terminal and a negative terminal. Even when I have other voltage sources, they always have two terminals, a positive end and a negative end. So the way that we draw this is, this is my bit of wire. I'm going to draw a series of long and short parallel lines. So that, or it might look like this, or it might look like this. But notice, no matter what, it's short, long, short, long, short, long, whatever it is. There's always a short end and a long end, and it comes in pairs. This is our symbol for voltage source. The short end is the negative terminal of the battery, and the long end is the positive terminal. Negative, positive, negative, positive. The reason why it has that symbol is when Alessandro Volta was making the first voltage source, he did it by stacking nickel and copper plates. The nickel was more expensive than the copper, so he made small little plates of nickel and longer plates of copper, and it looked like this in some sort of way. And so this is our symbol for a voltage source, okay? And a resistor. So if it's a battery, if it's a wall outlet, whatever it is. By the way, what do you think is the difference between these? Well, from a pictorial sense, we would say this is a higher voltage battery than this. So if this is a AA, this might be 2 AA's, this might be 3 AA's when you put 3 AA batteries into a thing, whatever. So they're a resistor. Resistors are just anything that turns electrical energy into another form. So rather than drawing toasters and computers and chargers or whatnot, we kind of gave up a little bit because, ready? Watch the symbol for resistor. It's just a squiggly line, but it's a squiggly line, not curves, right? So there's our resistor. It looks like Charlie Brown's t-shirt. Okay, so what does a circuit look like then? Well, if I have my short end, long end, then I come around here and then I put my resistor in, and there I go. And that's what it looks like. Now I need to label a couple things. We're going to label the battery VT. That stands for either terminal or total. And that's negative, positive. We're going to put an R above that. And the last thing we want to do is label the direction of current flow. Well, we said a current flow is actually a flow of electrons. So they want to go from areas of high electron concentration to low electron concentration. So they go around the circuit in this direction. So I'm just going to label that with I. I can label that with I here as well, right? And so these are called schematic diagrams, using symbols to represent things. So far we have two schematic diagram elements, a resistor and a voltage source. The third one that's very common that I wanted to show you is, we didn't have one in this, but a very common thing is a switch. So if I have a switch, the way that looks like is this. That would be something called an open switch. And if the switch is closed, it looks like that, right? And that's a closed switch. So if I put a switch into this, maybe I have a switch that's right here. That would be a closed switch. And if I open it, you know what happens. It's like turning on and off a light. So these are going to be our common schematic diagrams. This is the schematic diagram for what's known as a simple circuit. A couple of things there. Notice here, it doesn't have to be like a box. It could be a circle, a loop. The resistor could be there. The battery could be there. It doesn't really matter as long as it is a closed loop. A simple circuit has a voltage source and one resistor. So just very quickly, we looked at two other circuits. We had the ones that I called a series circuit, where the resistors were one right after the other. So the way that would look would be the following. I have my voltage source, and then I come around here and I have my first resistor, and then I have my second resistor, and then that would go back to the battery. So that was just so that you can remember what that looked like in the other lab. We had like the first bulb here and then the second bulb here. That's what that looked like. This is the proper way of drawing it. Negative, positive, voltage total, R1 and R2, just to have a name there for them, and then the direction of the current around that. And the other type we called a parallel circuit, right? Just to draw maybe what that looked like down here first, and then we'll represent it in schematic diagrams. I had each bulb independently attached, right? And I could either do this one, say down here, right? Or I could have even have drawn it like up here if I wanted to, what have you, okay? And so what does that look like? I'll just draw this slightly differently. Maybe I'll do this, and then the first, there's my first loop, and then here is my second loop. There we go. Negative, positive. Oh, here, notice though, I have to label two separate currents though, because I have two separate paths there. And that's super interesting, and we'll come back to that later. So I'll call that I1 and I2, whereas this one is only the one I, right? And that might be what that parallel circuit looks like using schematic diagrams. So there you go, how to draw schematic diagrams in order to do the way that professionals actually would do circuit drawings.